Okay, real quick, I'm going to talk you through part of number 2 so you can determine how to find this initial velocity. Where did that come from? So number 2 on tonight's homework, we did this part in class fine. We were able to represent that horizontal distance change with respect to time. What we don't know is the initial velocity. The vertical, we still didn't know the initial velocity, but we were able to set up the equations. They did give us some more information in the problem. They told us that the ball was caught at a distance of 90 feet. So we can plug in 90 for x of t, and we can isolate v naught, solve for v naught. So we know v naught is 90 divided by cosine 35t. Now, we also know the height at which the ball was caught. There was some discussion about this in class today. That does not mean the person is 4 feet. That means they caught it 4 feet off the ground. All right, and then we would plug in what we just solved for the initial velocity. So instead of v naught now, here in the second equation, we'll plug in the 90 over cosine of 35t. Well, nice things happened when we look at this. The t's are going to cancel, and sine over cosine can simplify to merely tangent. Now, how did this 6 turn into a 2? Well, we're going to use our calculator. Actually, we don't need our calculator on this one, but I moved it over looking like I was going to use my calculator to find the zeros. This one's actually easier than that because the linear term disappears. We can actually straight out solve it algebraically. So I combine these two. 65.019 approximately, move it to the other side, it becomes negative. Divide both sides by negative 16, you get t squared. Take the square root. And what this means is 2.016 seconds later, the ball is caught. So now we know the time at which the ball was caught 90 feet away. We can go back to that first equation and solve for the one missing variable, which is our initial velocity. So to solve for the initial velocity, now you'd say 90 divided by cosine of 35 times 2.016, and we get the initial velocity. All right, hope that keeps you going on these. The rest of them, you should be good. And if you have questions tomorrow, I will answer them during class.